Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 8, 2025, just yesterday. It reveals that letting models think internally without writing out every step offers a massive, over 2,700 times bandwidth advantage. The paper is titled, A Survey on Latent Reasoning, and it provides a fantastic overview of how models might think without words. This survey explores how models can perform complex inference entirely within their hidden states, moving beyond explicit step-by-step text. Also, the authors shared their GitHub repository for this survey. It's a fantastic resource, essentially a huge, organized list of all the papers they reviewed. It's all broken down by topic, with links to the papers and code, making it a great starting point for anyone interested in this area. Alright, so this first figure really visualizes the core concept. On the left, you see explicit reasoning, like a chain of thought. The model generates text step by step, with each step being a low bandwidth token. Only about 15 bits of information. In contrast, the right side shows latent reasoning. Here, the model processes information internally through its hidden states. A hidden state is essentially the model's internal numerical memory, its mental workspace. This process has a massive bandwidth of nearly 41,000 bits, explaining that huge efficiency gain. It can do this through vertical recurrence, for deeper thinking on one step, or horizontal recurrence, for carrying thoughts over time. Okay, and the survey's outline here really gives us a roadmap. It dives deep into those two core methods, vertical recurrence for deeper thinking and horizontal recurrence for carrying thoughts across time. It then moves into a fascinating area called mechanistic interpretability, which is all about reverse engineering the model to see how different layers contribute to the reasoning process. The outline even pushes towards wilder ideas, like infinite depth reasoning, where a model could theoretically think for an unbounded amount of time to refine its answer. Building on that outline, this next figure gives us a much more detailed taxonomy, essentially a map of the entire research field. It organizes all the different approaches to latent reasoning. We see those two main branches we talked about, the activation-based recurrent methods for deeper thinking, and the temporal hidden state methods for carrying a thought across time. It also charts out the work on mechanistic interpretability, which, again, is about reverse engineering the model to understand exactly how it thinks, and even pushes into those advanced ideas like infinite depth reasoning. And this next figure gives us a great visual for those two main branches we just saw in the taxonomy. On the left, with the activation-based method, you can see the model loops back, running through the same stack of layers multiple times. This effectively gives it more computational depth, letting it think harder on a single problem. Then on the right, the hidden state-based approach shows information flowing forward in time, carrying a thought from one step to the next. This method is all about expanding the model's memory across a sequence. So this table zooms in on that first branch, the activation-based architectures that loop to think deeper. It compares different models, like the universal transformer and algoformer, showing how their designs have evolved. You can see a shift from early, monolithic approaches to more structured ones using a pre-loop coda framework, basically a setup, a thinking loop, and a conclusion. It also tracks the dynamic stop mechanism, which is how the model decides when it's done thinking. Early methods were complex, but later designs show a move towards simpler, more efficient stopping rules. Now, moving to that second branch, the hidden state-based methods. This table gets into the mathematical details. It lays out the memory update rules for a whole family of models, like RetNet and Mamba2. Each equation here defines how the model carries its internal memory, its hidden state, forward in time. You can see a progression from simpler linear state recurrence to more complex gradient state recurrence, this second type. Gradient state recurrence treats the memory itself as something to be optimized, using gradients to learn how to remember information more effectively. Alright, so to wrap things up, this survey provides a really comprehensive look at latent reasoning. The key takeaway is this shift away from explicit chain of thought, where a model writes out its steps, to a process that happens entirely inside the model's high bandwidth hidden state. This internal thinking allows for much deeper and more flexible computation. We saw how this breaks down into those two main paths: vertical recurrence for thinking deeper, and horizontal recurrence for remembering longer. It's a field moving at lightning speed, but one that truly promises to unlock new frontiers in machine cognition. That's all for this episode of the AI Research Roundup. Thanks for tuning in.